Orifice meter. Orifice meter is a type of flow rate sensing device. Orifice plate is a orifice plate in which the orifice places in the path of the fluid flow. That is the reason orifice meter, which is called as an obstruction flow meter. So depending on the type of obstruction, we can have different types of flow meter. And most common among orifice type flow meter, where the orifice plate which is placed in the pipeline. So this is what your pipeline. So this is the indication of the flow in which the obstruction. So here this line, it is an indication of the flow profile. The orifice plate which is kept in the mid portion. So this is what the obstruction. So where it ends, there is a curve shape. This is what actually called as a vena contracta. That is what we have discussed in the previous part 1 video. Vena contracta, which is nothing but the minimum cross-sectional area of the fluid obtained at downstream. So that means this portion is in upstream and this portion is in downstream. So in the downstream, where the fluid obtained at the downstream from the orifice edge, which is called vena contracta. So here this is an upstream and the downstream. So in upstream there is a converging of fluid. In downstream there is a diverging of fluid. So here your pressure will be maximum. Here the pressure will be minimum. So P1 pressure maximum, P2 pressure minimum. And moreover, where we are going to give the obstruction of the orifice plate, in the orifice plate, this D1 and D2 are the diameter of the pipeline, and the orifice opening the flow rate can obtain using the equation what we had a discussion on the previous one. From the equation we can able to measure the pressure difference, that is P1 minus P2. So I would like to narrate once again the expression what we have obtained in the previous one, that is your volumetric flow rate equation as well as the equation V2, that is nothing but 1 by root of 1 minus A2 squared by A1 squared into root of 2G by gamma into P1 minus P2. So using that you can able to identify the flow rate using this pressure difference. And using this obstruction type of pressure measuring device, and here these are the different types of obstruction type. The first one is orifice flow meter, the second one is nozzle flow meter, and the third one is venturi flow meter. In orifice flow meter, these two are the pressure gauges which are kept inside the tube, that what I have shown in the previous one, P1, P2. So proportionality, they will just kept the pressure gauges. So inside that we have a pressure measuring device, that is pressure measuring sensor. In nozzle flow meter, here there is no like the flanges what it was situated in orifice. When you are looking at in venturi, there is a bending part you can able to see here. So here you have a pressure gauge, the upper portion and the down portion. So the pressure gauges are situated like that in your venturi flow meter. This is how the obstruction is situated. So they are all called as an obstruction meter. So in which we can measure the difference in flow before and after the obstruction by means of a differential pressure sensor. The rate of flow can be measured using these types of flow meter. So when you are looking at the diagram, this is how your orifice meter innerward and the outerward path, if it is placed in the industrial. So that is what I have indicated. There is a flow path, convergence, divergence. You have two pressure gauges. So this is a normal speed. Then where the speed variation is going to happen, and in which the orifice plate obstruction is inserted over here, again it is going to be normal. So you can able to identify the difference of pressure and the velocity variation due to the flow of liquid on the flow path. Here also you can able to see the pressure and the velocity difference. So based on the pressure difference, we can able to measure the flow rate. So that is the reason this PSI, that is pressure square inch, pounds per square inch, the pressure measuring unit we have. Accordingly, we can able to measure the pressure, and this is a type of indirect method of fluid flow measurement. So your change in pressure is directly proportional to the flow rate. So the velocity of fluid will be maximum at the maximum restriction. The pressure will be minimum at such a point. So the pressure drop is measured using the differential pressure sensor, which is nothing but U-tube manometer, which is kept on the tubes of this portion. This is how we can able to measure the pressure difference. So while A1, that is the first part of your cross-sectional area of pipe, A2 which is cross-sectional area of the orifice, and P1, P2 are the static pressure. So this is how the measurement has been done in your orifice plates. So how the corrections can be made when you are going on these types of flow meter. The flow expression is obtained from the equation is not an accurate expression in the actual size. So the discharge coefficient Q, which is P2 E2 CD into A2 divided by root of 1 minus beta power 4 into root of 2G by gamma of P1 minus P2. So the first assumption of frictionless flow is not always valid. The amount of friction is always depends on the Reynolds number, and it is more important point is the minimum flow rate is not the orifice area. In somewhat it is less. So these are the corrections are doing while they are calculating the flow rate. And moreover, the correction factor, your discharge coefficient value is always less than 1 while they are calculating the factor. So whatever the corrections obtained in the orifice flow meter, they are just calculating the discharge coefficient also. So included that in the constructions of your orifice flow meter, there are two things actually I would like to say. It consisting of two parts, that is one is your primary and the secondary. So the primary part, which is nothing but your orifice plate. The secondary one is what the pressure sensor we are going to use, that is U-tube manometer. So the primary orifice plate, which convert the fluid flow in terms of pressure difference, and the secondary part U-tube, here we are going to measure the pressure difference. It is based on the flow rate. The orifice plate, it is a metal plate. The thickness is 1.5 to 6 mm thickness with a hole in the center. And there is an upstream side and the downstream side. The upstream side is a sharp square edge facing into the flow stream. And here the fluid having uniform cross section of flow convergence into the orifice plate opening in the upstream. When fluid comes out, its cross section is minimum and it is uniform for a particular distance. Then the cross section starts divergent in the downstream. That is what I already told you, downstream and the upstream portion. And the orifice plate, this is the obstruction part. Here only we are just kept inside the path, fluid path, your orifice plate. That is what I told your primary and the secondary part of your orifice construction. And moreover, in the orifice plate there are two different types we have. One is eccentric, the another one is called segmental. So these two types are generally used in the industrial point of view. So they are used to measure the flow rate. Either it is suspended material or such as solid or oil which is mixed within water. These are some of the applications of your orifice flow meter. So while you are coming for the advantage, it is very simple in construction and the standards for construction and the calibrations are available. They are cheap and the prices does not increase dramatically with size, and we can easy to install and remove, and it is efficient and reliable for many years, available in many material, so that we can able to measure the flow rate it easy, because it produce the considerable pressure drop across the orifice plate, and moreover they can be used in wide ranges of sites. Their characteristics are well and predictable. The disadvantages of this orifice plate: it is relatively high permanent pressure drop. The characteristics is may change due to erosion and corrosion, and also it may cause clogs in slurries. It's not good with the fluid having high viscosity. So for high viscosity of fluids, your orifice plate, orifice flow meter, it is not suitable one. So the fluid must be in single phase and homogeneous, and moreover it produces a non-linear response. That is the reason they are going for square root characteristics that we have already discussed in part A. So these are some of the disadvantages of orifice plates, and the application of this orifice plates are: it is used to measure differential pressure measurement. Not only that, we can able to measure suspended material such as solids, then oil which is mixed with water. So that is what the discussion on this particular video. So this video we had a discussion on what are all the differential flow meters comes under obstruction, then what is the working principle of your orifice meter, what are all the different concept behind the orifice, and what are the two major types of constructions we have. Then we have seen the working principle, advantage, disadvantages, and application. So out of this video, I think you can understand the concept behind orifice flow meter. Thank you.